take the session, but I don't know why she has not joined. Shall we do ourselves, or should we what to do?
Sir, if you can please revise the previously done topics.
Oh, previously is only pandas and the numpy, no? There's nothing much there. So better we will start from this ML thing,
Okay.
and maybe you can take a lead, and we can discuss each topic. What do you think?
Actually, sir, I'm a beginner right now in this field.
Okay. I am also beginner. Anyone else? Karthik or Sureka, are you there?
Okay, so I'll try for the next time, for the next week. I'll be prepared for that.
Yeah, nothing much to prepare. Just we need to read through it and understand. It's not a complicated it's not like MTech. It's very general operational level of things. Let me share and we can go. Sureka, are you there?
Yeah, Manoj, I'm available.
Yeah, fine. You can unmute. Okay, it's not a problem. So how was the exams?
Just done with that.
Okay.
I think ML came very like it was expected that ML will be very tough regarding the classes we attended, but they were quite lenient on providing the questions, right?
Mm-hmm. So you were able to understand that.
No, I would still not be able to solve the questions myself.
Okay. So it's actually the MTech ML is something very tough. I think I don't know if, for others, but for me it's much beyond. So I was thinking we will have a rough idea what's going on in the industry. No, so let me share the screen. Then
Yeah.
we can discuss together. I am not a lead or something. We can just let's share the screen. Are you able to see the screen?
Yeah.
Okay, let me just enroll. So this is the platform, Jovian platform that we have. I think you already have the link, right?
Yeah.
So we can enroll there ourselves and have anyone gone through this one? And who's yeah, okay. Karthik, are you there? Karthik? Well, let me just post that we are starting. Somebody can.
Okay.
It's better to post it. Okay. Okay, so here we have, let me zoom it. So, any of us are in the in this data science, data analyst industry? Anyone here? Yeah, hi Rao, hi Panamala, Pradeep.
Hi, hi Manoj.
Yeah, hi Pradeep. So actually, we are starting this one without a lead. Sagarika was supposed to take the session today, but I don't know. She was not responding. Maybe she's busy with something. Yeah.
Okay.
Okay. Somebody is asking me to record. Okay, fine. Rao
Okay.
and Panimalar. Yeah. So actually we are trying to go through this one in case if you have not got. So I'm just this is linear regression with scikit-learn. These are Jupyter notebooks, okay? So we'll be going through one by one. And second lesson, logistic regression for classification, train your ML model, decision trees and hyperparameters, random forest, and there's an assignment, then gradient boosting, SGBoost, real world machine learning model course project, then unsupervised learning. So it will take at least 2 months, I guess. So let's go. Okay, so machine learning with Python 0 to GBMs is a practical and beginner friendly introduction to supervised machine learning. Decision trees and gradient boosting using Python. This is a self-paced course. Watch hands-on coding focused video tutorials. So for each lesson we have a video tutorial. When we open this, we'll find it. We'll just read this and go. Watch hands-on coding focused video tutorial. Practice coding with cloud Jupyter. Yeah, they are also giving a Jupyter notebook with explanations. Build an end-to-end real model course project and a verified certificate. That you will get if you are finishing the course and assignments and everything. It's a free actually. Interact with global community of learners. You will solve 2 coding assignments and build a course project where you will learn train ML models using large real-world datasets. The prerequisite is just data analysis with Python 0 to pandas. It's not a big deal. There are some pandas and NumPy are there and Seaborn. It's also available. If you click here, it will go there and you can check out the videos there. So today we will go into the lesson 1, linear regression with scikit-learn. Open. This is the first time I am going into this one. Even today I didn't learn this. I didn't go through the YouTube. So anyone here is available to know? I think Phenomenology is knows this one, no? Panola, can you unmute? Maybe she's in the office. I don't know. Rao, you are aware of this one, scikit-learn, right?
No, not much.
Okay, then it's nice you are here. We can go together then. In this lesson, we will learn the fundamentals of machine learning. See, actually, this is almost like 2 hours, I guess. It's better if we can, everyone can go through these lessons after the session. This session. It's describing the whole scikit-learn and the whole thing, what we are going to learn. So it will be a good introduction. In this lesson, we will learn the fundamentals of ML and linear regression in the context of a problem and generalize their definitions. The following topics are covered: linear regression with multiple features using numeric and categorical features, regression coefficients and features importance. Okay, we have a discussion forum where you can post the questions. There is a weekly study hour. I don't know about this one. So this is the Jupyter notebook. Okay. So we can run it here. We can run on Binder, run on Colab, run on Kaggle, run locally if you have a Jupyter notebook installed. Okay, I am using the Colab. So this tutorial is a part of 0 to data science bootcamp and Jovian and machine learning with Python 0 to GPMS. Okay, predicting medical expenses using linear regression. The following topics are covered in this tutorial. Typical problem statement for machine learning. So this is a Jupyter notebook which they already have prepared. Okay, so here also we have the same stuff. We can go through this one. Following topics are covered in the tutorial. Everyone can see this one, right?
Yeah.
Okay. Let me just put it here. So typical problem statement, downloading and exploring a dataset for machine learning, linear regression with one variable using scikit-learn, linear regression with multiple variables using categorical features, regression coefficient and feature importance, other models and techniques for regression using scikit-learn, applying linear regression to to other datasets. So this session is completely about the linear regression, nothing else. So I think almost 2 hour videos will be there. 2 hours of videos. Yeah, 2 hours of videos should be here. Yeah. How to run the code? This tutorial is an executable Jupyter hosted in Jovian. You can run. Okay, fine. Problem statement. This tutorial takes a practical and coding focused approach. We will define the terms machine learning and linear regression in the context of a problem and later generalize their definitions. We will work through a typical machine learning problem step by step. Question. Acme Insurance Inc. offers affordable health insurance to thousands of customers all over the US. As the lead data scientist at Acme, you are tasked with creating an automated system to estimate the annual medical expenditure for new customers using information such as age, sex, BMI, children, smoking habits, and region of residence. So based on all these parameters, or maybe all these uh, using this feature for the new customers, we are required to predict the estimated annual medical expenditure for the new customers. Estimates from your system will be used to determine the annual insurance premium. One second. So, estimates from your system will be used to determine. Am I audible?
Yeah.
Okay, thanks, Manoj. Estimates will determine the annual insurance premium amount paid every month or paid to the customer. Due to regulatory requirements, you must be able to explain why a system outputs a certain prediction. You must be able to explain why a system outputs a certain prediction. You are given a CSV file containing verified historical data consisting of aforementioned information and actual medical charges incurred by over 1,300 customers. So we should be having so much of rows. Yeah, there is no name. If you see this, you are given a CSV file. Okay, this is a sample.
Okay.
So there is no name of the person, but index number is there. Then age, sex, BMI, children, how many children they have, smokers, yes or no, region, and charges, actual medical charges. Okay. If smoker, yes. If it is like smoker is yes. It's she's having so much of medical bills. If it's no, then here it is less. We have to do. Okay. They'll be explaining how to do. Charges incurred. Dataset is here, and then we want to see the CSV file. Okay, it's a CSV file. I hope everyone can see this. Okay, so much of data is available. And dataset source is this one. There is a source, will be this one, right? Right. Machine learning, automated CSV file. I don't know which one is the data. Used to car SMS, mushroom data insurance. Maybe this one. Added groceries, insurance, and no.
Sir, I think it's the insurance.csv file.
Oh, yeah, that's right. Okay, so exercise.
before proceeding further, take a moment to think about how can approach this problem. Just 5 or more ideas that come to your mind. Okay, everyone give one idea each. Okay. So, okay, this is a combined study. Okay, so everyone has to involve. Whatever we know, we can tell. Rao want to say something?
No, I'm just thinking. Yeah, while others speak.
This is okay, or we will go into that data. Uh, each.
Okay, actually, these kind of problems, naive-based classifier will work, I think.
No, we will not go into complication. We will just go through what they say here. Otherwise, no, it will be divided into different sections.
Five possible solutions, right? Five possible models they want to
No, it's
list.
models. It's just ideas that how to approach the problem using the linear regression.
No, I'm saying the a naive-based classifier.
Is it does it belong?
Probably
Does it belong?
probabilistic model. Okay, so
I mean, I don't know. Is it related to this linear regression thing?
oh, this is only linear regression, is it?
Yeah,
Okay.
yeah,
Right.
yeah. This topic just regarding this notebook is only related to linear regression.
Okay. Right.
So looking at this data, what they are saying, how to approach the problem, right? And what is the problem? Based on the existing data, we need to estimate the annual medical expenditure for the customer. See, what we can do is to, based on age, sex, BMI, children, smoker, region. So, see, I think all these parameters are valid. No, we cannot ignore any one of them, even a single thing, right?
Yeah.
Because all are valid.
So the problem is what? The expenditure of the family?
Now the problem is using this information, you are tasked with creating an automated system to estimate the annual expenditure, medical expenditure for a new customer.
Okay. So that means children's expenditure is also maybe coming into picture, right? That will also play a role.
Yeah, maybe. Yeah, you are right. Using information such as age, sex, BMI, children, smoking habits, and region of usage. So all the given information you need to take into account and predict for the new customer, you need to predict the annual medical expense.
Yeah. So I think all parameters are valid. But anyway, so we cannot just decide based on looking at the parameters. These may be important or not important because the final charges may or may not depend on this.
Yeah,
Okay.
exactly. See, what you said, yeah, right. Because here 3 children and the amount is less, but here is 0 children, but amount is more. But the other
I
option,
think we should do EDA first, right? Exploratory data analysis.
Yeah, some kind of heat map and these things we have to do. And anyway, so the basic things of finding missing values and all is definitely needed. So then we need to understand the relationship between the parameters.
So, in my opinion, I think this is very similar to that house price prediction, right? Okay, so the use case may be different, but it is exactly similar to that.
Yes, correct.
Sure. And I think that that heat map that you're talking about actually kind of helps us understand the correlation.
Yeah.
And okay, if there is any kind of dependency or all are independent, then I think we can go for all the features.
Correct. So the advantage with heat map is so it will apply the respective correlation analysis to it. For example, if you want to do the categorical variables, maybe it will do the test. Continuous variables, it will do the chi-square test. Categorical variables, some other test it will do. So that kind of it'll tell all the parameters. It will prepare a matrix So let's say you have how many parameters? 3, 4, 7, right? So 7 into 7 matrix it will say, and we can know which parameter is more related. So it is something like 0.99. So we can simply ignore one of the parameters and take only one, something like that.
That's actually EDA, right?
Yeah, EDA.
This is presentation in how to canvas. List 5 or more ideas that come to your mind. So we have to move an EDA, and we will find the correlation between these individual features, and which are highly correlated we can ignore or something like that, right?
Yep.
Yes.
Okay, let's further go into this one. Okay, Sagriga has joined. Would you like to take up, Sagriga?
Yeah, hi, hello everyone. Sorry, I got late actually.
It's okay.
I was going through the first lecture on linear regression. So overall, the way he explained is good actually. But when you see the document, there are few places where they have asked us to fill up the like work upon those problems and provide answer to them. There I feel some of the stops are little repeated, right? Like univariant analysis, I think he has given for age and charges. The similar thing they have asked us to do for other features. Maybe those parts I don't know if we can skip or we have to complete everything whatever they have asked for.
No, we will just go with whatever we feel is comfortable and minimal. No, we don't need to repeat the same steps again and again. But 1 or 2 times we can confident or responsive. It depends on us. You can ignore it if you want. Okay.
But certificate and all, is it required or we'll be doing this just for our practice?
No, I don't think certificate is required for anyone. Does anyone need certificate? If anyone wants, they can do it by themselves. They can do the assignment.
Okay.
Are you also for any certificate or what?
No. I'm just asking, like, since you have already done the EDA part, so how you kind of covered it, just wanted to know.
I just want to finish off as soon as possible so that we gain some information, like what is linear regression, how to implement it in real things. That's all.
Yeah, so there are 3 examples in this session. They have given 3 Kaggle data set. Maybe we can pick up one of that data set, and if we kind of implement the model, then it will be good for all of us.
Yeah, see, what I'm doing is we are going through this book what they have given. I don't know, you have you checked this one? When I click run, we get this in the collab, it's open, right? You can open it. So we are just reading the problem statement. So have you gone through this problem statement?
Yes.
So any ideas on this one? So this five, now Rao and Raman was saying we need to do the EDA and we need to find the correlation between these parameters and ignore whatever is highly correlated, something like that. You have any?
So, yeah, that they have already mentioned in this document actually, in this code actually. Most of the things they have already derived, and they have also concluded that which all parameters are actually having more weightage for predicting the charges.
Yeah, it's fine. Because before that we were discussing this one ourselves, not without looking into the what they have mentioned.
Okay.
So here, because they just told us to think about it, and it's nice if we can think about it. No? Okay, let's now let's run this one. Connect. Would you like to open it from your side?
No, this is fine.
I think we need to wait a moment. Let's check. To begin, just download the data using URL retrieve. URL library. Okay. Restart the terminal. Okay. This is the CSS file, and we need to then import the pandas. Then read this medical.csv file. I think this got connected, so let's run. Or maybe you can run everything, right? Run now. Panda. Okay, these are done now. So this medical.csv is in the pandas now and is run now. Medical underscore df data frame, right? So if I put medical underscore df dot info, this is the one, right? One command or pandas command, right? I don't know pandas, right?
Yes.
Yeah, this is the command, right?
Yeah, that's the command. Info and describe, right?
Oh, okay. User command notice, what is this one? Code. So here we have 13 columns. Contains 7 columns. Why is having like this? They mentioned dataset contains so and so rows and 7 columns. Each row of a data contains information about one customer. Our objective is to find a way to estimate the value of charges and also storage data in simply asking the information like let's check the data type of the column. So why is any idea why it's showing 13? It's supposed to be 7.
I think the region is divided into columns, right?
Yes. So they have split it into 4.
Different regions.
Mm.
So initially it was okay. Try to do one thing. Here it's
Yep.
try do again. Yeah, now it's same. I don't know why it's okay. Yeah. So each row is content that information about one customer. Our objective is now info. If we have some. Okay, run this again. Yes, okay. Looks like age, children, BMI, and child are numbered. Yeah. Here it's mentioned in 54. These are numbers. 454, 1, 2. Children, charges. Um, smoker and region are strings, possibly categories. The object is category column. None of the columns contain any missing values, which saves us a fair bit of work. How they understood that is not okay. They didn't mention it. There are some statistics for the numerical columns. So we are using the describe to find the data numerical data columns to find the statistics. So age is count, okay. Mean 39, standard deviation 14, minimum is 18, maximum 54, 50% is 39. Oh, that's the mean. 25, okay. BMI is again 50% is 30. Children 1 is normal. Okay. Charges 93,000. So 9,300. But the ranges of the values in the column seem reasonable, no negative edges. So we may not have to do much data cleaning. Not much. The charges column seems to be significantly skewed, however, the median is much lower than the maximum. What does this mean? The charges seems to be significantly skewed.
I guess this describe command gives us the detail about the distribution of the features, right?
So there might be outliers and charges.
Uh, I'm not getting a clue.
So what did you ask, Manoj?
Now, given this information, they have mentioned here range of values in the numerical column. Okay, the charges column seems to be significantly skewed, as the median 50% is lower than the maximum. Oh, okay. So this 50% 9,000 is much. Okay, the maximum 63,000 and minimum is 1,000. Okay, so 1,000, 9,000 and 63,000. That's what they are saying, right? Towards the left, right? The mean comes towards the left. That's what
Yeah,
mentioned.
yeah. So it is okay. Basically, so 1.5 into median, anything above than that is, sorry, not 1.5 above the median, Q3, right?
Yeah.
So above Q3, whatever is into 1.5, we can consider it as outliers.
Yeah.
So we need to calculate the 75th percentile on this. Okay, maybe definitely it is way far from the median. What is the median? Okay, 75th percentile. It's already given, right?
Yeah.
16,000 is the 75th percentile. Into 1.5 is what? Some about definitely less than 40K.
20%,
Okay,
right?
so yeah. So it should be around 25 or so, right? Then above 25 should be outliers. So we need to see how many records are there above that, whatever 1.5 into 16,000. If there are more number of records, they may not be outliers. Then we need to tune that 1.5 into dot 2 or dot 2 dot 1, something like that, and then eliminate the outliers or replace with a median. Some smoothing techniques are there, right? We have to use them.
The values seems to be reasonable because we have, for example, the age 50% is for 39. That's reasonable. Maximum 64 rupees. Minimum 18. So this is fine. And then BMI. I don't know how to do the BMI thing. 50%.
Yeah, BMI 53, I'm not sure if it is reasonable. Max is 53, right? So that is also still greater than 1.5. So it should be around, okay, maybe not outlier. 34 into 1.5 is how much?
There's a minimum 15, maximum 53, and the middle 30. So
Yeah, it's correct only. So it's actually coming as 51, so it's not significantly out. So all other parameters seems
yeah, like children
okay.
1, 0, 2, and 5. Yeah, that's fine. That's still okay. Charges, yeah, so 13,000, 53,000. This is a bit.
So okay, even the minimum, right? So minimum is what? So uh, again, the same logic. 4720 into 1.5. So which is how much?
Within 3,000, I guess.
Right. So then it has 1100. I'm not sure if that is a valid value again.
Okay, fine. Now, because our understanding on this. Anything else or everything, right?
Yeah. So we can do a box plot actually for all the parameters. I don't know how to do it. At least the continuous variables we can do the box plot. That will tell us the outliers.
And they are going to do this one, right? For it.
Yeah.
So import plotting. Okay, matplotlib keyboard. Everything is imported. SNS set style and all. This is the previous we had an idea of EDA. Then age is a numeric column. The minimum age is 18 and maximum 54. Distribution of age using histogram with 47 bins, one for each year. Okay. And a box plot. Use Spotify Plotly to make the chart interactive, but you can create similar charts using keyboard. Medical describe. Okay, they have taken only the age and making a describer. So mean, minimum. Okay, everything we already went through this, right? 75% is 51 and maximum 54. Then figure px dot histogram. So this is the command to create this figure. They have used what? Plotly. So they have used Plotly to create this visualization. So they have put the data.
Why they have used 47 bin? One for each year.
54 minus 18. That will be like 40. How much? 46, right? Yeah, it's 46. 46 or 40, I don't know. That will be there. Yeah, 54 minus 18. Like minimum is 18 and the maximum 54. So we need and win. So this is a command that they put data frame, the age, x is equal to age, and marginal is equal to box. I don't know. Then n bins. This is the number of bins is 47. Title distribution. So the title came here and number of. Okay, box. Box means maybe the type of this layout or something. No. Okay, maybe about this one, box plot. Marginal, I mentioned box plot. Okay. Update layout. Okay. So here, this is starting age 18. Yeah, it's a good one. 18. The count is 69. Okay, for the 18 age, we have 69 counts. Oh, it's only the distribution about the age. Okay. Only the count chart, right? So
Yeah.
Yeah. So many people with 69 people with age 18 and 19 almost. Then from 20 we have less. Almost number of people are almost same. As you go, okay, older age of only 22, 29 to 22. Okay. The distribution of wages in the dataset is almost uniform with 20 to 30 customers at every age, except for the ages 18 and 19, which seem to have over twice as many customers as our ages. The uniform distribution might arise from the fact that there isn't a big variation in the number of people at any given age in the USA. Can you explain why there are over twice as many customers with ages 18 and 8 compared to other ages? Anyone like to take this? Can you explain why there are twice as many customers with ages 18 and 19 compared to other ages? Any guess? Rahul like to guess something?
18 and 19 only, yeah? No.
Here, as you can see, it's almost count is 58. Normally, let's say it's almost 30, like almost more than double, right?
Yeah.
Maybe they have any bad habits, smoking and.
No, that will be continued, no?
I think the insurance company wants to target 18 and 19 years of age, because so that they can continue the insurance policy over their lifetime, right?
That's
The maximum benefit.
maybe some offer or below 20. Okay, body mass index. Just look at the distribution BMI of customers using histogram and plot. So again, the px dot histogram. Why here it's showing like okay, fine. color discrete red. Too much colorful. Try to okay.
Excuse me, what is above that histogram? Those is that a box plot on top?
Yeah, box plot. Yes, box plot on the age.
Okay.
In previous one, it was a box plot on the age. We had the median 39, Q1 27, minimum 18.
So for drawing the box plot, we can simply use this method and it will draw both the histogram as well as the box plot.
Yeah, right. This is the one. So marginal is
Okay.
equal to box. This one is the
Okay, marginal is equal to box means box plot.
should be. I am guessing that.
Okay.
Okay. Can we remove this and check? Yeah, that's right. Now the box plot is not there, right?
Okay. Yes.
Okay, so we are going to this one, and this one is BMI, body mass index. This should be okay. BMI, and okay, BMI and count. How many people have this body mass? So more people are with body mass of 30 something, and less people with 15 and 45. The measurement of body mass index seems to be to form a Gaussian distribution, means normal distribution, centered around the value 30 with few outliers towards the right. Yeah, these are they are saying the outliers. So here, how BMI can be interpreted? Underweight, normal weight, 18 to 25 is a normal weight. 25 to 30 is overweight. Okay, so okay, fine. 25 to 30 overweight. 30 to 40 is obesity. Okay, I think most of the people are count BMI 28. Yeah, are in the okay. In the center is obesity. BMI from the obesity, right? No, I think. Oh, okay, okay. Okay, it should be like this only. In this area, it should be the like 18 to 25 is the normal weight. So something in this place, it should be the normal. This is obese. I mean, this is overweight, and this part is obese. Morbid obesity, okay, greater than 40. So all these are too much obese. Can you explain why the distribution of ages forms a uniform distribution while the distribution of BMI forms a Gaussian distribution? Any guess? Ages form a uniform distribution. Yeah, the reason why ages form uniform distribution, I think it's almost same level, right? So the reason is as Aman was saying, they have no. I think it's mentioned here, right? Yeah, the uniform distribution might arise from the fact that there is a big variation in the number of people at any given age. In USA, the number of people for every age is almost same. That could be the reason why. And as Aman was saying, the reason why this increase is maybe they have some insurance companies giving some offers for the people below 20. That could be one reason why it is. Otherwise, it's almost uniform. Regarding the BMI, so while the distribution of BMI forms a Gaussian distribution, here most of the people are in this BMI range. So what? How can we discuss this one? Can you explain why the distribution of ages form uniform and the distribution of BMIs form Gaussian?
So people tend to put weight if they are in the same lifestyle, right? When 18, when they are in the lifestyle, I think they'll be active. And as and when they get money, they used to buy car, and then you know they become luxury. And then if they didn't care about their health, they probably they will become obese and
No, actually one thing, 18 is the BMI. There's nothing to do with age over here. Here it is BMI and here it is. We are not comparing with age.
I think the range of BMI is very less. That's why we get a Gaussian distribution rather than a uniform distribution.
Pardon, what? What mentioned is BMI, not the age.
Oh, sorry. Okay.
Because we are using only the what is the unilateral or something, univariate analysis. Only one variable.
Here maximum count is in IQR, no?
IQR. Yeah, maximum count is here. This one. 91. 92 is the maximum count. The question is, this one is like a goes in uniform, like what we got here.
But this is in most of them are in IQR range only.
I don't know what is IQR range. You mean between the quartiles or what?
Yes. Between Q3 and Q1.
Most of the people are of the same range. That means. Okay, so you will think otherwise as the age, maybe many people in the lower age they have less weight, and people who are too old also maybe having less weight. So, that we can say. The question is why the people with underweight and overweight are almost same, and overweight, obesity, and underweight are almost same. Sagarika, you want to add something?
No, I'm also thinking.
Okay, otherwise, if anything to add, you can otherwise go forward.
What is the maximum age?
Age.
I
We are
was saying.
not looking at age. The BMI.
No, what I'm saying, generally 20 onwards, people tend to get weight. So maximum is, I think, more than 60, 64.
Yeah.
Yeah. So this is the time where people generally kind of gain weight, maybe, no? Maybe that's why. Like 18, 20 is kind of less. But then in the middle, and 64 is again like not a, like maybe weight reduces, I think, after 65 or 70, right? So
See, this is underweight, overweight, and this is on.
yeah, so majority of the people are kind of mid-age only, right?
Majority people no. Here you see middle-aged people are same like other people.
Yeah. So 20 plus onwards, if you take like the 20 to 50, if you take, then the count is more when compared to only 18, 19 and 60 plus, right? Like,
sorry, I'm not getting
yeah,
you.
yes. So if you take this, if you sum up this 20 to 60 or 50 maybe, then their numbers is more, right? And 18, 19 kind of people are there, then 60 plus, right? So that age tenure, within that only people are having more BMIs, I guess. So more number of people are having more BMIs, maybe that's why.
More number of
So
people.
can we compare these two graphs also?
They have mentioned only to this is not related to age, so there's no point in comparing.
age तो है नहीं.
univariate analysis. So we just something why that so many people are overweight and very little people are overweight as well as obese.
That's why that's how the data is.
Yeah, this is quite natural, right? See, if you normally observe, right, you might see underweight people very less, and again overweight people very less. So they are kind of extremes, right? And you see mostly like normal weight you see, or normal weight could be overweight probably these days, right? Overweight could become the normal weight, I mean become the median and the mean overweight, and normal weight become slightly lesser, and obese is something next, and underweight and over obese are kind of extremes, and overweight as such, right, 25 to 29, that becomes the normal now. That means that is where we see the most of the people. If you go back like 50 years ago, then probably the second case, right, underweight or can you scroll down a little bit? Yeah, the normal weight could be really normal those days, like 50 years before, but now like the normal weight itself become a overweight now. Means normal, not normal weight, the normal becomes the overweight. When we say normal, Gaussian distribution, it's become like the mean and median, right? Mean, median, mode all becomes most of the people these days are overweight. So that is what from the data we can conclude. And again the obese, over obese, and or the underweight is kind of become extremes.
Okay, so that's what you say. So the normal is now like overweight, and everything else will be lower. Fine.
Yeah, everything is spread
Yeah.
from the norm, from the center point. Yeah.
Fine, fine, good. Let's continue to the next one. Is charges.
No, but why there is why it is not a uniform distribution like you said?
Yeah,
It is uniform.
it's not uniform. It's just
It is not uniform.
So Gaussian is a uniform, right? So the
Gaussian is
Normal.
normal.
sorry,
Gaussian
sorry,
is
sorry,
not
sir.
uniform.
Gaussian is not uniform. I'm sorry. Yeah, it is normal. So normal distribution is something like
Bell
we
curve.
have a major population. Yeah, we have the major population in the center, in the center of the bell curve, and then it's spread across.
Yes.
So like since our 18 and 19 were too many, so that means those were the population that were overweight. Can we say that then?
That is a different measure actually. It's not about the weight, right? Can you go up a little bit? The 18 and 19 spike was there, right? That is a different measure, I believe. So what is this about? The count is, what is that count here?
Age. This age
Piece
group.
of age.
Age group, huh? Oh, okay.
19 to 58 people were 19 age who took the influence, and uh, uh, for 18 age, 59 people came with the 18 age. So this is uniform, and this is not normal or associated. So let's continue, and if you ask the answer exactly, we don't know, but what Karthik was trying to say is that now this normal overweight people are like the normal now.
Yeah, if you look at this distribution, then a normal, overweight, and then third one, like overall, I think there are 5 categories. Out of it, 3 are kind of started from normal, overweight, and obesity. These 3 are more. So I think middle represents these 3, and corner ones are like uh, underweight and morbid.
So I think that is what is the importance of this histogram, because it is showing us that the mean is around overweight rather than mean is around normal weight.
And we can also add up if we check IQR, 50% lies in between. If we count Q1 and Q3 total count, it should be 50% of overall.
Right, right. 50% of overall. This part,
Yes, it is.
50% of overall.
Between Q3 and Q1, the count of people should be 50%.
Okay, fine.
50% of total population.
Sorry, what you're saying? This part,
So,
50%.
so the count of people between this IQR, no, Q3 and Q1, it should be 50% of overall population.
Okay. Okay, yeah. So we will finish today with this charges also, or what do you think?
Maybe we can conclude 50% of people are in range of that PMI.
50% are in this overweight, right?
This range 25 to
30. No, it's
35.
50% people
25
are
to 30.
in overweight and obese conditions. Obese, overweight is 30 and obese starts from 30 to 40. So now the timing is like 10 o'clock there, right? So should we continue or what do you think?
Maybe we can go through this code individually, and tomorrow we'll discuss about the questions.
Go through this video also. There's one video having the full details. It is almost like 2 hours, I guess. That will be good introduction, and then we can go through this course again tomorrow. So
yeah, I think in the video only they have explained this code.
Yeah, they have.
There is less theory. Yeah.
Yeah. The thing is,
So
by watching the video is a different thing, but when we there's a combined study, that's more.
Correct.
So can you please share the link for the video as well as this collab data?
Shared. So when you go to that, it's shared. So when you go there, you will find. So I already shared it. If you want, I will share it in this chat. It's already shared in the public group. Okay. Okay. Where is the chat?
Otherwise, if you put the group name right where you have shared, I will make sure that I am part of that group.
You are not the part of the group. I have shared. Are you in the Python EDI?
Sorry, Python, right?
Yeah, Python DA beginners. You are not there?
No.
I will put the chat.
That link.
Yeah, WhatsApp link also there.
Okay, thank you.
So here I have already put this link to the Jovian, where you can go there and you will get this Python and the whole. Today we are looking only at the linear regression. You will get the whole. When you go into the linear regression, you will get the video, and again if you go to this run, you can see this run button, right?
Yeah.
So when you go there, you can run on the collab, and then you will get the.
Okay. Okay. Cool. Okay. Thank you.
Okay. Have a look at this, and tomorrow we will meet again.
Sure. Thank you.
Okay. Thank you all. Thank you for joining.
Thank you, sir. Thank you so much.
Thank you all. Bye.
Bye.
Thank you. Bye.
Thank you.
Thank you.